Hi, I'm James Kakalios. I'm a physics professor at the University of Minnesota, and I was asked to do some science consulting for the Warner Brothers film Watchmen.
Just a matter of time, I suppose.
In Watchmen, Dr. Manhattan has amazing superpowers. He can teleport from one location to another. He can split himself into multiple copies. He seems to be aware of the past, present, and future simultaneously. Are any of these powers possible?
I'm sorry, John. But I can't.
Don't leave me!
John Osterman gained superpowers when his intrinsic field was removed in a physics experiment gone awry out at Gila Flats. Well, there's no such thing as an intrinsic field. But if there were, if we could describe it as a wave, then we could have a situation such as John Osterman's wave being the yellow wave, and if we generate another wave externally, the purple wave, if they're completely in phase, we add the two and we get a bigger result. But if we turn the purple wave and reverse it so that it's now 180 degrees out of phase, you add the two and the result is zero. So this is a situation where you can generate a wave. If it's 180 degrees out of phase with the existing wave, you can remove both waves. In the movie, presumably, the intrinsic field that holds all of John Osterman's atoms and nuclei together can be described by some sort of wave. Somehow, that wave is analyzed and they generate a wave completely out of phase. You remove the forces holding his atoms and nuclei together and he would disintegrate, be torn apart. The light is tearing him to pieces, as they say in the graphic novels. Dr. Manhattan can appear in more than one place at once. How is he doing this? Perhaps he's diffracting his quantum mechanical wave function. A hallmark of wave phenomena is that you can get interference patterns. And so if a wave is passing through some region, some narrow boundary, it can appear to be in many locations at once. The waves interfere and can form a complex diffraction pattern. Dr. Manhattan, presumably, is able to do this through his control of his quantum mechanical wave function. Throw a rock into a pond, you get a series of ripples. Throw two rocks into a pond near each other, and you get a complicated interference pattern as each ripple interacts with the other. This is the signature of wave phenomena. Here I have a laser beam. You can see the laser beam reflected off of my U of M calendar. The laser beam is now going towards a screen, and the screen is acting like the disturbance on the pond, and we see a series of ripples, a series of rings. We saw with the laser light and the screen, one of the hallmarks of wave phenomena is that they can exhibit diffraction patterns. That was the series of green dots we saw. That was the diffraction pattern for the laser light passing through the screen. If electrons have a wave associated with them, can they show diffraction patterns as well? The answer is yes. We pass an electron beam in this old-style cathode ray tube through a carbon crystal. The carbon atoms serve the same role as the screen did with the laser light. Because the electrons have a wave associated with it, we get an interference pattern, a diffraction pattern, just like we saw with the laser light and the screen. Same diffraction patterns, therefore electrons must also have waves associated with them. Dr. Manhattan has a wave associated with him that he can control at will. So presumably, when he chooses to diffract himself, he can be in several locations at once. Not strictly correct from a physics point of view, but very cool nonetheless. The Watchmen film crew had asked the National Academy of Sciences if they knew of anyone who could do a little science consulting for them. The National Academy knew of me through the physics of superheroes, and so I got the call, would I be interested in working on this film? Have you ever heard of it? It's called Watchmen. Well, I've been reading comic books for quite a while, and so yes, I had heard of Watchmen. I was very excited and very happy to say yes. I don't know how much or how little will show up in the finished product, but as Alex McDowell, the production designer of Watchmen, described it, they want to know what's around the corner of a long hallway even if the audience doesn't go down that corridor. So they wanted to know the grounding behind the science. How does Dr. Manhattan move from one location to another? How can he appear as multiple versions of himself? Is there any real physics behind this? They say he has quantum mechanical powers. What does that mean? And so by giving them this background, they were able to use this, maybe not directly in the film, but at the layer beneath to help provide a solid grounding for what they're doing, so that you don't stop and complain about the science that you're seeing on the screen, that you're just caught up in enjoying the movie. This will probably come as a shock to you, but some of my students actually find physics dull. I know, I felt the same way. And they always are concerned that it's going to have no applications, no relevance. The common question, when am I going to use this in my real life? Whenever I use superheroes to illustrate physics principles, students never wonder when they're going to use this in their real life. If you can analyze a comic book, a TV show, a movie, and extract real, correct science out of it, if a comic book can apply real physics principles, then maybe physics is good in the real world. Maybe you will use it in your real life. And one of the things that was very gratifying was the literally hundreds and hundreds of emails and messages from students, from teachers, from people long out of college who liked this idea of using superheroes to explain physics principles, asked if I had a book, which eventually led to my writing a book.